Hello everyone and welcome back to the channel. I am so happy to see you here today. If you are new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you are struggling with, please comment down below. I read every single comment, and for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I'm here to help you succeed. Today we are going to learn about a topic that is fundamental to further mathematics and additional mathematics. We are going to talk about trigonometry. This is part 1. Covering ratios, rules, radians, and bearings. This lesson is suitable for SHS1 and SHS2 students. Now, I know that when you hear the word trigonometry, you might feel a little nervous. Many students find this topic challenging because there are many formulas and rules to remember, but I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes, so we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long, so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to define and calculate the 6 trigonometric ratios. These are sine, cosine, tangent, and their reciprocals. You will learn how to convert angles between degrees and radians. You will learn how to calculate arc length and sector area using radian measure. You will learn how to apply the sine rule and cosine rule to solve non-right-angled triangles. You will learn how to solve problems involving 3 figure bearings. And finally, you will learn how to distinguish between reciprocal functions and inverse functions. That is a lot, but we will take it one piece at a time. Let us start with Section 2, Introduction to Trigonometry. What is trigonometry? Trigonometry is the branch of mathematics that studies the relationships between the sides and angles of triangles. The word comes from Greek. Trigonon means triangle. Metron means measure, so it literally means triangle measure. Trigonometry begins with the right-angled triangle. This is a triangle that has one angle equal to 90 degrees. For any angle theta in this triangle, we have 3 sides. The first side is the hypotenuse. This is the longest side. It is always opposite the right angle. The second side is the opposite. This is the side opposite to the angle theta. The third side is the adjacent. This is the side next to the angle theta, but it is not the hypotenuse. There are 3 primary ratios you must know. We often use a mnemonic to remember them. It is called SOHCAHTOA. I know it sounds like a strange name, maybe like a type of food, but it is very useful. SOH stands for sine equals opposite over hypotenuse. CAH stands for cosine equals adjacent over hypotenuse. OA stands for tangent equals opposite over adjacent. Please write these down. They are the foundation of everything we will do today. Now, let us move to Section 3, Worked Examples on Basic Ratios and Reciprocals. We will start with Subtopic 1, Basic Trigonometric Ratios. Let us look at Example 1.1, Calculating Primary Ratios. The question is, in a right-angled triangle, the opposite side is 3. The adjacent side is 4, and the hypotenuse is 5. Find sine theta, cosine theta, and tangent theta. Step 1, identify the sides. Opposite equals 3. Adjacent equals 4. Hypotenuse equals 5. This is a classic 3-4-5 triangle. You will see this often. Step 2. Apply the formulas. For sine theta, we use SOH, opposite over hypotenuse. So sin A theta equals 3 over 5. As a decimal, this is 0.6. For cosine theta, we use CAH, adjacent over hypotenuse. So cosine theta equals 4 over 5. As a decimal, this is 0.8. For tangent theta, we use 2a, opposite over adjacent. So tangent theta equals 3 over 4. As a decimal, this is 0.75. Answer: sine theta equals 0.6. Cosine theta equals 0.8. Tangent theta equals 0.75. Please write that down. See how we just matched the sides to the correct ratio. Now let us look at example 1.2. Finding a missing side. The question is, find the length of side x in a right-angled triangle where the angle is 30 degrees, the hypotenuse is 10 centimeters, and x is the opposite side. Step 1. Choose the correct ratio. We have the hypotenuse, which is 10. We want the opposite, which is x. Looking at molus OA, which on C, and hypotenuse. It is so. So we use dot sign. Step 2. Set up the equation. Sine of 30 degrees equals opposite over hypotenuse. So sine 30 degrees equals x over 10. Step 3. Solve for x. To get x alone, we multiply both sides by 10. X equals 10 times sine 30 degrees. Now, you need your calculator for this. Make sure it's in degree mode. Sine of 30 degrees is 0.5. So x equals 10 times 0.5. X equals 5 centimeters. Answer: x equals 5 centimeters. This was straightforward. Just remember to pick the right ratio. Now let us look at example 1.3, finding an angle. The question is, in a right-angled triangle, the opposite side is 5 and the adjacent side is 5. Find the angle theta. Step 1. Choose the correct ratio. We have opposite and adjacent. Looking at SOH2A TOA, which one has opposite and adjacent? It is TOA, so we use tangent. Step 2. Set up the equation. Tangent theta equals opposite over adjacent. Tangent theta equals 5 over 5. 5 divided by 5 is 1, so tangent theta equals 1. Step 3. Find the inverse tangent. We need to find the angle whose tangent is 1. We use the inverse tangent button on your calculator. It usually says tan inverse or atan. Theta equals tan inverse of 1. Theta equals 45 degrees. Answer: theta equals 45 degrees. Notice how when the opposite and adjacent are equal, the angle is 45 degrees. That is a nice little trick to remember. Now, let us move to subtopic 2. Reciprocal trigonometric ratios. There are 3 additional ratios, which are the reciprocals of the primary ones. Reciprocal means 1 over the number. The first is coectant. The symbol is CSC theta. It is hypotenuse over opposite. It is 1 over sine theta. The second is secant. The symbol is sec theta. It is hypotenuse over adjacent. It is 1 over cosine theta. The third is cotangent. The symbol is cot theta. It is adjacent over opposite. It is 1 over tangent theta. I need to give you a critical warning here. This is very important. Do not confuse reciprocal functions with inverse functions. Inverse sine, written as sine to the power of -1 of x, means the angle whose sine is x. Cosecant, written as CSEx, means 1 over sine x. Sine to the power of -1x is not equal to 1 over sine x. They are completely different things. Please do not mix them up. I know it is confusing because of the notation, but just remember, CSC is reciprocal. Sine inverse is angle. Let us look at example 2.1. Evaluating reciprocals. The question is, evaluate sec 60 degrees and CSD 30 degrees. Step 1. Find the primary ratio values. Secant is related to cosine, so we need cosine 60 degrees. Cosine 60 degrees is 0.5. Cosecant is related to sine, so we need sine 30 degrees. Sine 30 degrees is 0.5. Step 2. Apply reciprocal formulas. Sec 60 degrees equals 1 over cosine 60 degrees. 1 over 0.5 is 2. CSC 30 degrees equals 1 over sin 30 degrees. 1 over 0.5 is 2. Answer, sec 60 degrees equals 2. CSC 30 degrees equals 2. C, just flip the value. Now let us look at example 2.2. Using identities. The question is, given sine theta equals 3/5, find CSC theta. Step 1. Recall the relationship. CSC theta equals 1 over sine theta. Step 2. Substitute the value. CSC theta equals 1 over 3/5. When you divide 1 by a fraction, you flip the fraction. So, CSC theta equals 5/3. Answer, CSC theta equals 5/3, simple substitution. Now let us look at example 2.3, proving an identity. The question is, prove that tangent theta times cosine theta equals sine theta. To prove something, we start with one side and try to make it look like the other side. Let us start with the left-hand side. Step 1. Express tangent theta in terms of sine and cosine. We know that tangent theta equals sine theta over cosine theta. Step 2. Substitute into the left-hand side. Left-hand side equals open bracket sine theta over cosine theta. Close bracket times cosine theta. Step 3. Cancel cosine theta. The cosine theta on the bottom and the cosine theta on the top cancel each other out. So we are left with just sine theta. This equals the right-hand side. Answer, identity proven. This shows how the ratios are connected. Now let us move to section 4. Worked examples on angles in radians. What is a radian? A radian is the angle subtended at the center of a circle by an arc equal in length to the radius. That sounds complicated, but basically it is another way to measure angles instead of degrees. Here is the conversion you must know. 180 degrees equals pi radians. To convert degrees to radians, you multiply by pi over 180. To convert radians to degrees, you multiply by 180 over pi. There are formulas you must use when working with radians. Arc length S equals r times theta. Area of sector A equals 1/2 times r squared times theta. Here, r is the radius and theta is the angle in radians. Important, you must use radians for these formulas. If you use degrees, you will get the wrong answer. And here's a little humor for you. I have seen students lose marks on this so many times. I think the calculator manufacturers should put a warning label on the degree button saying danger, do not use for arc length. So please, always check your calculator mode. Let us look at example 3.1. Conversion. The question is, convert 60 degrees to radians. Step 1. Multiply by pi over 180. 60 degrees times pi over 180 degrees. Step 2. Simplify the fraction. 60 over 180 simplifies to 1 over 3. So the answer is pi over 3. Answer, pi over 3 radians. Always leave pi in the answer unless told otherwise. Now let us look at example 3.2. Arc length. The question is, find the arc length of a circle with radius 10 centimeters and sector angle 60 degrees. Step 1. Convert angle to radians. We cannot use 60 degrees in the formula. We must convert it. 60 degrees times pi over 180 equals pi over 3 radians. Step 2. Apply the formula S equals R times theta. S equals 10 times pi over 3 is equals 10 pi over 3. If you calculate this, it is approximately 10.47 centimeters. Answer, 10.47 centimeters. Remember to convert first. Now, let us look at example 3.3, sector area. The question is, find the area of a sector with radius 6 centimeters and angle pi over 3 radians. Step 1. Apply the formula A equals 1/2 times r squared times theta. A equals 1/2 times 6 squared times pi over 3. Step 2, calculate. 6 squared is 36. 1/2 times 36 is 18. 18 times pi over 3. 18 divided by 3 is 6. So A equals 6 pi. If you calculate this, it is approximately 18.85 centimeters squared. Answer: 18.85 centimeters squared. Notice how the pi stayed in the calculation until the end. Now, let us move to section 5. Worked examples on sine and cosine rules. These rules are used for non-right angled triangles. That means triangles that do not have a 90-degree angle. We label the triangle with angles A, B, C, and opposite sides A, B, C. First is the sine rule. The formula is A over sine A equals B over sine B equals C over sine C. You use this when you know two angles and a side, or two sides and a non-included angle. Let us look at example 4.1, finding a side using sine rule. The question is, in triangle ABC, angle A is 40 degrees, angle B is 60 degrees, and side A is 10 centimeters. Find side B. Step 1. Set up the rule. We use A over sine A equals B over sine B. 10 over sine 40 degrees equals B over sine 60 degrees. Step 2. Solve for B, multiply both sides by sine 60 degrees. B equals 10 times sin 60 degrees divided by sin 40 degrees. Now use your calculator. Sine 60 degrees is approximately 0.8660. Sine 40 degrees is approximately 0.6428. 10 times 0.8660 is 8.660. Divide by 0.6428. That is approximately 13.47 centimeters. Answer: BAN is approximately 13.47 centimeters. Make sure your calculator is in degree mode for this one. Now, let us look at the cosine rule. There are two forms. Finding a side. A squared equals b squared plus c squared minus 2bc cosine ca. Finding an angle. Cos A equals open bracket b squared plus c squared minus a squared close bracket divided by 2bc. You use this when you know two sides and the included angle, or all three sides. Let us look at example 4.2, finding a side using cosine rule. The question is, in triangle ABC, side B is 5. Side C is 7, and angle A is 60 degrees. Find side A. Step 1. Set up the formula. A squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cos 60 degrees. Step 2. Calculate. 5 squared is 25. 7 squared is 49. 2 times 5 times 7 is 70. Cos 60 degrees is 0.5. So 70 times 0.5 is 35. Now put it together. A squared equals 25 plus 49 minus 35. 25 plus 49 is 74. 74 minus 35 is 39. So A squared equals 39. To find A, take the square root. A equals square root of 39. This is approximately 6.24 centimeters. Answer: A is approximately 6.24 centimeters. Watch out for that minus sign in the formula. It is easy to forget. Now, let us look at example 4.3, finding an angle using cosine rule. The question is, in triangle PQR, side P is 7, side Q is 8, side R is 9. Find the largest angle. The largest angle is opposite the longest side, which is R. So we find angle R. Step 1, set up the formula for angle R. Cos R equals open bracket P squared plus Q squared minus R squared close bracket divided by 2PQ. Step 2, substitute values. P squared is 49. Q squared is 64. R squared is 81. 2PQ is 2 times 7 times 8, which is 112. So cos R equals open bracket 49 plus 64 minus 81, close bracket divided by 112. 49 plus 64 is 113. 113 minus 81 is 32. So cos R equals 32 over 112. This is approximately 0.2857. Step 3. Find the inverse cosine. R equals cos U inverse of 0.2857. R is approximately 73.4 degrees. Answer: R is approximately 73.4 degrees. This method works for any angle if you know all three sides. Now, let us move to section 6, worked examples on bearings. What is a three-figure bearing? It is the direction of one point from another, measured in degrees clockwise from north. It is always written as 3 digits. For example, 045 degrees, 005 degrees, 270 degrees. Here are the rules for solving bearing problems. 1. Draw a north line at every point of interest. 2. North lines are parallel. Use alternate angles, also called z-angles, to transfer angles. 3. Measure clockwise from north. 4. Uses sine or cosine rules to solve the resulting triangle. Let us look at example 5.1, basic bearing conversion. The question is, a plane flies on a bearing of 090 degrees. What direction is this relative to north? Step 1. Understand the reference. 0 degrees is north. Step 2. Measure clockwise. 090 degrees is 90 degrees clockwise from north. 90 degrees clockwise from north is east. Answer: east. This is a simple one to help you visualize. Now let us look at example 5.2, distance calculation. The question is, a ship sails 10 kilometers on a bearing of 060 degrees from port A to port B. It then sails 15 kilometers on a bearing of 150 degrees to port C. Calculate the distance, see step 1. Determine the angle ABC. This is the tricky part. Let me walk around and check your diagrams. Okay, make sure you draw north lines at A and B. Bearing A to B is 060 degrees. Bearing B to C is 150 degrees. Using parallel north lines, the interior angle at B is calculated as follows. The back bearing from B to A would be 180 plus 60. But we don't need that. We look at the angles. The angle between the north line at B and the line BA is 180 minus 150. Wait, let us simplify. The angle inside the triangle at B is 180 degrees minus 150 degrees plus 60 degrees. That is 30 plus 60 equals 90 degrees. So triangle ABC is right-angled at B. Step 2. Use Pythagoras theorem. Since it is right-angled, we can use AC squared equals AB squared plus BC squared. C squared equals 10 squared plus 15 squared. 10 squared is 100. 15 squared is 225. 100 plus 225 is 325. C equals square root of 325. This is approximately 18.03 kilometers. Answer: distance is approximately 18.03 kilometers. Drawing the diagram correctly is half the battle here. Now let us look at example 5.3. Finding a bearing. The question is, using the scenario in example 5.2, find the bearing of C from a bearing. Step 1. Find angle BAC using tan ratio. In the right-angled triangle, tan of angle BAC equals opposite over adjacent. Opposite is BC, which is 15. Adjacent is a B, which is 10. So tan angle equals 15 over 10 equals 1.5. Angle BAC equals tan inverse of 1.5. This is approximately 56.3 degrees. Step 2. Add to the initial bearing of AB. The bearing of AB was 060 degrees. We add the angle we just found. Bearing equals 60 degrees plus 56.3 degrees. Bearing equals 116.3 degrees. Answer. Bearing is approximately 116 degrees. Always write bearings as 3 figures. So, 116, not just 116. Now, I want to warn you about common mistakes. Section 7. Mistake number 1. Calculator mode. Using degrees mode for radian formulas. Always check mode. If you are doing arc length, check for rad. If you're doing triangles, check for deg. Mistake number 2. Reciprocal versus inverse. Thinking CSC theta is the same as sin inverse theta. They are not. Mistake number 3. Sine rule ambiguity. When using sine rule to find an angle, there can be 2 solutions. Students often miss the obtuse case. Mistake number 4. Bearings, measuring anti-clockwise or from the wrong north line. Always clockwise from north. Mistake number 5. Cosine rule signs. Forgetting the minus sign in a squared equals b squared plus c squared minus 2bc cos A. Mistake number 6. Labeling. Mixing up sides and angles. Side A goes with angle A. Now it is time for class evaluation. Section 8. I want you to pause the video and solve these in your notebook. Question 1. Convert 120 degrees to radians. Question 2. Evaluate cot 45 degrees. Question 3. Find the area of a sector with radius 6 centimeters and angle pi over 3 radians. Question 4. In triangle ABC, A equals 8, B equals 10, angle C equals 60 degrees. Find side C using the cosine rule. Question 5. A plane flies on a bearing of 090 degrees. What direction is this relative to north? Take your time. Write down your steps. Do not rush. I will wait for you. For your assignment, Section 9, please do these at home. Question 1. Prove that tangent theta times cosine theta equals sine theta. Question 2. Find the arc length of a circle with radius 5 meters and angle 1.2 radians. Question 3. In triangle PQRP equals 7, Q equals 8, R equals 9. Find the largest angle using the cosine rule. Question 4. A hiker walks 5 kilometers on a bearing of 030 degrees and then 8 kilometers on a bearing of 120 degrees. Calculate the distance from the starting point. Question 5 is a challenge. If sine theta equals 3/5 and theta is acute, find the value of sec theta plus cot theta. This last one is tricky. You will need to draw a triangle to find the other sides first. Let us do a summary of what we learned today. Section 10. We learned about ratios, sine, cosine, tangent, and reciprocals cosecant, secant, cotangent. We learned about radians. 180 degrees equals pi radians, essential for arc length and sector area. We learned the sine rule. A over sine A equals B over sine B. Used for AS or S or SSA. We learned the cosine rule. A squared equals B squared plus C squared minus 2B C cosat. A used for SAS or SSS. We learned about bearings measured clockwise from north. And we learned identities. Sine squared theta plus cosine squared theta equals 1. I know this was a long lesson, but you have done amazingly well. Trigonometry can be confusing because of the many rules, but you now have the tools to handle them. Remember, practice is the key. The more you practice drawing diagrams and using your calculator, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, Please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there's a specific problem you're stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.